Princeton University's Keller Center, educating leaders for a technology-driven society.
TUBE stands for Time-Dependent, Usage-Based Broadband Price Engineering. So why are we interested in time-dependent pricing? Well, demand for wireless internet, as you can see from this graph, has really been exploding in the past few years. The problem is that the tail of this usage is very heavy, and it's that tail that drives the ISP's cost. If their revenue continues to be driven by the median user, as shown in this graph up here, then their cost structure will just fall apart. Time-dependent pricing tries to solve this problem by exploiting the differential between the peak demand and the average demand over a day. You can see a typical graph here below. So TUBE is a software system which computes and delivers the right pricing incentives to actually get consumers to shift their usage from peak to off-peak hours. We did a survey and found that over 50% will defer up to 5 hours if we can cut their monthly bill enough. So can we actually deploy this system in practice? Well, we certainly can in India and China. And even in the US, the FCC is now encouraging measures which match price to cost. Verizon recently introduced a tiered plan where you pay $10 per gigabyte after a small cap. We've talked to a lot of ISPs, and they all agree that time-dependent pricing is the way of the future. Actually, we talked to Qualcomm, and they want to push this even further to congestion-dependent pricing. So even during periods of heavy usage, there's very small windows, maybe 2 minutes, during which there are very few users. ISPs can advertise what we call these flashy white spaces and offer a very low spot price during those white spaces. Then this creates a new class of users called the scavenger class, who just wait for those white spaces in order to access the internet. Countries like India have already started using time-dependent pricing for voice calls. We want to push that even further and make time-dependent pricing work for mobile data and video traffic over IP networks. But it's not quite trivial. We need to first figure out how to get the optimal price so that ISPs will actually offer the right price and users will actually take it. And then we need to integrate it into this control loop of computing prices and consumers reacting to them. Finally, is this usable and is this scalable? So we've started from fundamental research in electrical engineering, computer science, and economics, and we've developed this control system seen here. We're almost done building a prototype, and we're moving our focus now to phase 3, which is a trial of 50 Princeton users. Users will have an app on their smartphones through which they can keep track of our time-dependent pricing, and they will access the internet through our servers via a VPN provided by AT&T, as shown in this diagram. TUBE has a social dimension too. We make it profitable for wireless operators to make all internet affordable to all users. How? We use pricing as a lever to shovel traffic from peak to off-peak periods. For rural users, this reduces the pipe size needed to overcome the bottleneck middle mile. Urban users can wait for flashy white spaces to access the internet. We have a lot of partners in this venture. Here is a diagram of them. The core team is our Princeton team and the National Exchange Carrier Association. We're also partnering with Qualcomm and SES, which is the largest civilian satellite company in the world. And we are talking with a lot of ISPs in both the US and India. So in terms of financial projections, we expect to take 10% of the revenue which TUBE brings to ISPs, and we're projecting a break-even point of Q1 of 2014.